guys, it's me, Rinia, and hey guys, it's me, Dean. I'm Rinia's best friend. So today, Dean will ask me a question. I don't know the question. Okay, Dean, do you have a question for me? Yes, Rinia. Can you tell me how heat is transferred from one object to another? Oh, of course. Let me tell you. So the heat is transferred in three ways: conduction, convection, and radiation. So let's start off with conduction. So to understand the conduction better, I have an activity. Here you can see I've taken Bunsen burner, one stand, a rod, wax and both pins. So I've fixed the wax with the both pins on the rod and I've lit the Bunsen burner. You will see that the both pin near the Bunsen burner will fall first because the molecules will burn from here and the heat will get transferred first over here. So the wax will melt and the both pin will fall. Then one by one the molecules will get heated because the heat is get conducted because the molecules are in contact. So one by one all of the both pins will fall because the wax will melt. This is an example of conduction of heat in solid. So this took place in solid because solid is a very good conductor of heat. Conduction of heat only takes place in solid because the molecules are in close contact with each other. So we understood that conduction of heat takes place in solid which are in contact. Now you know liquid is a very poor conductor of heat. So let's see if this conduction of heat takes place in liquid or not. So here in this activity, I've taken Bunsen burner, water, wire gauze and ice. So wire gauze is a metal sheet which has net-like patterns. So I've wrapped the ice with wire gauze and placed it in the bottom of the test tube. You know why I've used wire gauze? So that the ice is in the bottom of the test tube because ice is lighter than water and it flows above water. That is why. Now I have tilted the test tube with tweezers and I've lit the Bunsen burner. After few minutes you will observe that the water starts boiling but the ice will remain still. It will not melt because water is a poor conductor of heat. So the heat isn't transferred. Okay, Rinia, I get it. But how is heat transferred in liquid and gases? It is very simple. Because of convection. So let us study convection. So here is the activity. Here is an activity. I've taken a beaker, lighted candle, tripod stand and potassium permanganate. So what I've done, I've lit the candle and the water is warm. Now I've carefully dropped one crystal potassium permanganate. Be very careful. Don't touch it with your bare hands, okay? So after a few minutes, I've used potassium permanganate because it gives a nice color so that we can observe the convection currents in water. Now after a few minutes, you'll observe that the crystal, in some minutes, you will observe that the water flows up, rises up because it is hot. And you know hot water rises up. So it rises up. And when it touches the surface, it becomes cold. And the cold water rushes to take place where the hot water was. And the cold water takes place. And the cold water again becomes hot. And it rises up, gets cooled in the surface, and then again rushes back to take place where the hot water was. And vice versa. This is how heat is transferred in liquid through convection. Now let us study how is heat transferred in gases. So here is a very simple activity. I've taken a glass chimney, 2 corks, burning paper and one lighted candle. Now what I've done, I've raised the chimney above the level of the ground by the cork. Now I've placed burning paper for the smoke and lighted candle. Now the smoke of the burning paper rises up because it is hot. And if you feel the bottom, then the cold air takes place. And you know why is the candle still lighted and not extinguished? Because it does not run out of the supply of oxygen, because the oxygen cannot enter from here because it is all blocked. So the oxygen and the cold air enters into the chimney through the bottom because I've raised it. Now what will happen if you don't raise it?
But Rinia, what will happen if we don't raise the chimney?
It is very simple. If I have not raised the chimney and I've put it burning paper and a lighted candle, but after a few minutes the lighted candle will get extinguished because the smoke rises up, but the cool air cannot take place because it is all blocked. That's why the candle runs out of oxygen and it gets extinguished. So we studied the convection currents in gases. This is how the heat is transferred in gases.
Does convection current takes place in our everyday life?
Oh, of course, of course. See, when you go to the beach in the daytime, the land is very hot. You cannot walk barefoot. And the water is very cold. You know why? Because land is solid and it gets heated quickly. So that's why the land gets heated very quickly and the water is still cold. So the air above the land becomes hot because of the land and it rises up. Rises up, rises up. And the cold water above and the air above the cold water is cold. So it rushes back to take place where the hot air was, because any space cannot stay empty. So it rushes back, and when the cool air rushes back to take place here, it becomes hot again because of the land, and it rises up, and this cycle continues till sunset. So after sunset, there is no sun, and the land gets cooled quickly. But the water is still warm because water takes a lot of time to get heated and a lot of time to get cooled. So the water is warm and the air above it is hot. The water is hot and it rises up as shown here. Rises up, and the land and the air above the land is cool because the land is cool. So it rushes back to take place where the hot air was above the water, and this cycle continues. And you know, there's one interesting fact. This is called sea breeze because the breeze comes from the sea. And see, the flag is pointing towards this side, towards the land, because the wind is flowing from here. And over here, the flag is pointing over here towards the sea because the wind is coming from the land, and this is called land breeze.
Oh wow, what a nice example, Rinia. Oh, Rinia, I'm feeling very hot. What can I do? I'm feeling so hot.
I know why you're feeling very hot, Dean, because you're wearing a black t-shirt. Now, you want to see an example?
Yes, Rinia.
Okay, let me show you an example. I cannot walk anymore, Annie. I'm feeling very hot. Why am I feeling so hot already? Mom, because you're wearing a black dress and I'm wearing a white one. What? What does that even mean? The amount of heat radiated by a body depends on its temperature, its color, and the nature of its surface. So what does that mean? You are wearing a black dress, and black color absorbs more sunlight than that of white, and the white reflects a larger portion of sunlight. So that's why I'm not getting hot, you are feeling hot. Then sweetie, then why do we use black umbrellas, right? Mom, it's very simple. You're wearing the dress. You're wearing it. So it's touching your body. And the heat gets transferred in your body. And conduction of heat takes place in your body. That's why you're feeling hot. And I am not. And are you wearing an umbrella? Are you wearing it? Are you wearing it like a dress? No, not at all. That's why. And you know, black gets heated quickly and radiates it. No, black absorbs heat quickly and radiates it really quickly too. Oh, okay. Now I get that. That's why you feel cool under the umbrella, okay? Okay, sweetie. Now let's go home. I don't want to wear black dress anymore.